So let's talk about vector addition. Two vectors are added by adding their respective elements. So let's say if I have a vector u like so, and I have another vector v like so, the result of adding vectors u and vector v would give me a new vector whose elements will be x1 plus x2 and y1 plus y2. So essentially what I'm doing here is that I'm adding the first element of u with the first element of v, and to get the first element of u plus v, and again I'm adding the second element of u with the second element of v to get the second element of u plus v. And you can also see the results graphically too. So let me draw an xy plane first. Okay, and let me draw a vector u. So let's say this is your vector u. Okay, and let me draw the vector v like this. So let's say this is the vector v, and I'm drawing vector v so that it starts from the tip of vector u. So now the result of addition of vector u and v will be represented by this vector u plus v. This is not a straight line, but you can assume that this is a straight line. So this vector is u plus v. So this is u, and this guy is v. So the vector u plus v starts from the starting point of vector u and ends at the tip of vector v. And this kind of forms a triangle. And this way, or this method of adding two vectors graphically, is known as the triangle rule of addition. So there's a nice name for it. It's called triangle rule. Okay. And really you can see why this is the case. You don't have to trust my word for it. So when you draw vector u, right, so what it really means is that the x projection of vector u would be x1, right, and the x projection of vector v will be x2, right. So this is x2. So clearly you see the x projection of vector u plus v. What is this? This is x1 plus x2, which is actually what we said. We defined the vector addition like so, right? And you can do the same exercise for the y traversals, or the y projections of vector u, v, and u plus v on the y-axis to see why this triangle rule really holds. Now that we have learned about addition, and we have also learned about scalar multiplication of vectors, let me talk about subtraction. And subtracting two vectors, for example, this u minus v, is nothing but u plus minus 1 into v. So you multiply the scalar minus 1 with vector v and then add it to u to get the result of u minus v. Let me take a more tangible example to make things clear here. So let's say if you have got u is 5, 6, all right, and let's say v is 2, 3. And let's say if you were to find out what is u minus v. So u minus v will be u plus minus 1 into v. And this will be 5, 6 plus minus 1 into 2, 3. And this will be 5, 6 plus minus 2 minus 3. So what I've done is that I've multiplied minus 1 with this vector 2, 3 to give me this new vector minus 2 minus 3. And now we can do a simple vector addition. So it's 5 minus 2 and 6 minus 3, and the result is 3, 3. You can in fact even use the triangle rule of addition to calculate the resultant vector formed by subtracting two vectors. And let me show it to you how it's done, though I think it's extremely trivial once you have seen how triangle rule works. So let's say if this is vector u, okay, and let's say if I were to subtract v from this, I'll first plot v. So let's say this is v. So I'll first plot v like this, and now I need to multiply v with -1. So when you multiply v with -1, you will get the vector which has the same magnitude but will be in opposite direction, so exactly opposite direction. So this vector will be -1 minus v, sorry, and this length L will be equal to this length L. All right, and now u minus v will be nothing but the, you can apply a triangle rule here, right? So it will be this vector, right? The vector that actually starts from the start of vector u and ends at the tip of -v.